I guess this question is like, I think we touched on this a little bit earlier in the episode as well, when you were talking about the research at Harvard and the ability for transformers to seemingly understand is such a bad word, but
Understand, I would agree.
Yeah. So I think you have a good sense of kind of the question of where this is going, so you can answer it.
Yeah, I think like the question, if understood it correctly, is about like, can we one day in the future, and how is it not yet the case, rely on these models? Isn't it that humans on some very simple tasks obtain 100% score, right? Well, while models will sometimes do so impressive things, and when it's not expected, will fail on silly things. And so that's very weird. My understanding, and I'm not saying I got it right, but just my intuition and understanding at the moment, is that as we discussed before, with scale, we might have an emergence of much general reasoning and understanding. And my understanding is that those algorithms kind of learn the compression of the data. Maybe let me give you an example to understand, one or two examples. Like, if I can print you an infinite number of tokens to train the model of numbers and calculus. 1 plus 2 equals 3, and so on. Now, if I give you that, there's two ways to predict the next token after equal. You can memorize everything, but that if it gets to an infinite vocabulary, you will need a lot of weights to memorize that. Or you can compress the information such that you internalize the algorithm behind that, and so you can predict accurately the next token, whatever. And that requires much less weights to learn calculus than to memorize an infinite number. Now, at the current time, it seems that large language models are very good at doing calculations for 1, 2, 3 digits, and when it goes beyond, it fails more and more. My understanding is that they kind of internalize generalization in terms of calculus for 1 digit, but somehow in the large vector space, they kind of see it as different objects, calculus for 2 digits than for 5 digits, maybe because it appeared less. And so they don't have yet this generalization of, oh, this is 1, 2, 3, 5, 6, 7, 8 is calculus, and so 9 and 10 that I didn't see in the training is calculus as well. And so there's one dimension they didn't generalize, but there's some others they already generalized. And I feel like true AGI, if we get there with scaling or in any other ways, could emerge from this generalization of compression at another scale, when the generalization will be complete somehow, if we get there with scaling.